control technology using bentonite. Let me introduce bentonite mix. Bentonite mix is produced through mixing of a base material of dirt and sand with bentonite in a prescribed ratio and mixed uniformly. Seepage control is produced through compacting this bentonite mix and forming a low permeability layer. Also, it is non-flammable and does not readily deteriorate, so it can be anticipated to maintain functionality on a semi-permanent basis. Furthermore, in the event that a crack does occur, it has a self-healing function and maintains seepage control characteristics. For the production of dirt mixture at the site, it may be possible to reuse the dirt generated at the site as the base material, depending on the physical properties of the dirt. This would reduce the amount of dirt generated due to construction, and based on effective use, is also beneficial from an environmental and cost standpoint. The gap between soil particles is reduced through mixing in bentonite, and because water that comes into contact with the bentonite mix layer is absorbed, causing swelling, the path water has to take is extended, enabling seepage control. In order to determine the bentonite mix ratio, first, the base material is sampled and the physical properties are investigated to see if it is suitable as the base material for the bentonite mix. If it is found to be suitable as the base material, the selected bentonite is used to prepare bentonite mix with varying amounts to perform a permeability test. The additive ratio for satisfying the required coefficient of permeability is thus determined. Property and permeability tests of the bentonite mix created using this additive ratio are performed to determine the amount to be added and level of control needed at the site. Preparing a high-quality bentonite mix with little stirring unevenness is essential to ensure seepage control characteristics. Bentonite mix is prepared using an automatic soil improvement machine to perform the agitation and mixing. After preparations are complete, materials are brought in and calibration is performed. Prior to preparation, the moisture content ratio of the base material for that day is measured and the constant for the improvement machine is set. Bentonite and base material are introduced to the improvement machine after settings are complete and agitation mixing is performed. Additive amounts for the mixture produced are confirmed based on a methylene blue absorption test and funnel viscosity test. This is collected together, and to prevent contact with rainwater, etc., it is stored with a cover placed on it. As for quality control tests at the site, a base material water content test and bentonite swell ability test are performed prior to preparation and when the material is received. Quality control after mix is prepared using a methylene blue absorption test and funnel viscosity test to confirm the bentonite additive amount and to confirm whether or not a homogeneous mix without stirring unevenness was produced. The bentonite mix must be compacted to the prescribed compaction density to ensure seepage control. Therefore, test construction is performed beforehand to determine selection of the compaction machine and the number of times to perform compaction and execution method. After the control standard is determined during test construction, smoothing of the construction area is performed. The bentonite mix is transported to the construction location, spread evenly, compacted, and the surface shaped. Next, a quality control test is performed, and then a rain cover is added. Quality control during construction is achieved through performing the RI method and sand replacement method to confirm prescribed compaction and control layer thickness. In addition, block samples are acquired from the construction location, and an indoor permeability test is performed to make sure it has achieved the prescribed permeability. Bentonite mix layers constructed in this manner have a coefficient of permeability of less than 1 × 10 to the -7 centimeters per second. Even with 100 centimeters of head, this has a travel time of over 5 years. This exhibits 10,000 times the seepage control of normal dirt and sand. Based on the seepage control, bentonite mixed is used as the seepage control work in many of final disposal sites. The seepage control work is one of the important facilities actively discussed regarding shaping citizen agreement for new locations for final disposal sites. The seepage control works, or seepage control structure, plays an important role necessary for preventing leakage of rainwater that has gotten inside the disposal site or leachate to prevent environmental pollution as a function required of a final disposal site. As a ministerial ordinance, the seepage structural standard in Japan for final disposal sites is 1 × 10 to the -8 meters per second or less, with a composite structure of a soil seepage control works and seepage control sheet of 50 centimeters or thicker. Seepage control works with a composite structure of a soil seepage control layer and a seepage control sheet functions as a seepage control system that is mutually complementary. Our bentonite mix technology is playing a major role in achieving safer and better peace of mind seepage control works. Cases of soil pollution due to particular toxic substances through construction work has increased in recent years. Concern regarding health effects and societal demand for establishing countermeasures are gaining strength. Based on these circumstances, a soil contamination countermeasure law was established in 2003 and revised in 2010 to ensure safety and peace of mind of citizens, to understand soil pollution conditions, and to implement soil contamination countermeasures, such as steps related to preventing health hazards to persons due to soil contamination. Of toxic substances, those considered especially problematic recently are mercury, lead, arsenic, and fluorine, etc., that occur as naturally derived heavy metals. A lot of dirt containing naturally derived heavy metals is excavated during tunnel construction through mountains for developing expressways and railway infrastructure, and this dirt for which countermeasures are needed should not be allowed to permeate externally or into the ground, and what countermeasures can be taken represents a challenge. There are cases when contamination derived during operation in the metropolitan area or at a former factory site is learned of when subsequent development is performed. Depending on the level of contamination, after insolubilization of other treatment, containment is achieved using a seepage control layer based on use of bentonite mix, etc. containment for tunnel construction through mountains, where a lot of dirt containing naturally derived heavy metals is generated using bentonite mix, prevents release of heavy metals and makes possible the beneficial use of the dirt requiring countermeasures as embankment or fill dirt. In recent years, bentonite mix has been utilized as seepage control works for final disposal sites, overcaps, soil contamination countermeasures, reservoir repair, levee core repair, and various other needs.